talked about the point of intersection of a line and a circle. Remember we talked about that point of intersection of a line and a circle. We had a few different options of what could happen. One option was that the line could cut through the circle at two different points. And we said that line was called a chord. It's a line that cuts a circle and cuts it at two different points. So 2 points of intersection. And then the other option was that we had what was called a tangent. A tangent. And that is a line that cuts a circle at one point. So there's only 1 point of intersection. And actually I think we had tangents, didn't we, in calculus and differentiation. We had one at a max and a min. I talked about that line being a tangent. Okay, so here we have those two phrases, a chord and a tangent. A chord is a line that cuts the circle at two places, and a tangent is a line that cuts the circle at one point. The one we're interested in today is a tangent. Now, if you notice, a tangent is a straight line. Okay, so when you see the word tangent to a circle, what you're talking about is a straight line that cuts a circle. Okay, and what we're talking about when we talk about a tangent is we're asked to find the equation of a tangent. So what we're being asked to do is to find the equation of a straight line. Now, rack your brain for a moment and think back to coordinate geometry of the line. When we had to find the equation of a straight line, we had a formula for that. And the formula we had for that was y minus y1 is equal to m times x minus x1. That was our formula. Now again, racking your brains back and thinking there, what did we need to find the equation of a straight line? We needed a point, which we called x1, y1, and we needed a slope, which was called m. There's our point x1, y1 we subbed in, and there's our slope m. So although we're dealing with a circle now, because it's coordinate geometry of the circle, we've kind of got to go back and think about some coordinate geometry of the straight line, because a tangent is a straight line that cuts a circle at one point. And when we're trying to find the equation of a tangent, that's the same as finding the equation of a straight line. Now, when you're told to find the equation of a tangent, you'll be told at what point that tangent cuts the circle. You'll be told x1, y1. You'll be told where on the circle that point lies. So that's great. You're told that. You're told the equation of, to find the equation, you're told the point that's going to be on that line. What you're not told is you're not told the slope. And this is a point of geometry that we haven't done yet, but we will do. But you might even remember from junior cert, a tangent to a circle, if we were to draw a line from where it cuts the circle to the center of the circle, that's a radius, isn't it? It's a radius of a circle. If we were to draw that line from the point of intersection to the center of the circle, we would find that it's at right angles to that line. So the tangent of a circle, the tangent to a circle at a point is at right angles to the radius at that point. So the slope of our tangent, the slope m of our tangent, is perpendicular. It's at right angles to the radius at that point. Okay? The tangent of our circle at the point x1, y1 is at right angles to or perpendicular to the radius at that point. Now, that's loads already. So let's just go through it one more time and then we'll look at a question and see how it works. We're going to be asked in a minute to find the equation of a tangent to a circle. We know that a tangent to a circle is a line that cuts the circle at one point. We know that the tangent is a straight line. So we know that when we're asked to find the equation of a tangent, we're being asked to find the equation of a straight line. We remember from our coordinate geometry of the line that the formula for finding the equation of a straight line is y minus y1 is equal to m by x minus x1. x1, y1 is a point on the line. And in this case, the point on the line that we're going to use is the point where the line cuts the circle. It's the point of intersection of the line and the circle. To find the equation of a straight line as well as a point, we need a slope, which we call m. The slope of our tangent, the way we're going to find it is that it's at right angles to or perpendicular to the radius that's at that point of the circle, to the center, the line that joins the point of intersection to the center. That is loads already, but hopefully as we go on, it'll begin to make sense. So let's go back to the questions that we have in our textbook. And we're going to work. Yeah. Of work. Say that again.
How many marks would you get for that?
For drawing this?
Yeah.
For doing this?
Yeah.
Nothing as yet. Okay, because I'm just giving you the background. Okay. But you'll see now in a second that you can get marks. So once we look at a problem, you'll see where we'll get the marks. Okay, so here is the circle x squared plus y squared equals 8 has a tangent at the point minus 2, 2. As shown in the diagram, find the equation of this tangent. So here's the good news, because I'll show you how you will get marks from now on. So there's my question. The equation of this circle that we're going to be doing, hopefully that's enough space. Now I'll try and work so that you can see the question as well as my work here. So we're being asked to find, we're being told that there's a circle that has equation x squared plus y squared equals 8. So the first thing you do when you see an equation of a circle that is x squared plus y squared equals 8, the first thing you're going to do anytime you see that is to write down its center and to write down its radius. Okay, so I'm going to write down here its center and its radius, and they've even given us a diagram over here, so actually it's easier even to see what its center is. But we should know anyway that because it's x squared plus y squared equals 8, its center is 0, 0, and its radius is the square root of 8. So hopefully I'm already getting marks. It has a tangent at the point minus 2, 2. So the point of intersection of this circle and this tangent is minus 2, 2. Now remember, we've been asked to find the equation of the tangent to the circle at the point minus 2, 2. That's the question. The circle x squared plus y squared equals 8 has a tangent at the point minus 2, 2, as shown in the diagram. Find the equation of this tangent. Okay, there's our diagram. There's our circle with center 0, 0. There's our circle, there's our tangent, and there's our point of intersection. So the equation of the tangent. Now, remember I said the equation of a tangent is the equation of a line. Y minus y1 is equal to m times x minus x1. We know that the point that's on the line, that's also on the circle, but the point that's on the line is minus 2, 2. So x1, y1 is minus 2, 2. So I know already that y minus y1, which is y minus 2, because y1 is the y value from the point on this line, is equal to m by x minus x1, x minus 2, because the x1 value is minus 2. Now I definitely have marks. Okay, if this is a 10-mark question, I've definitely already got 4 marks. I've passed this part of the question, even if I can't do anything else. I may even have more marks than that, but I've definitely got 4. Okay. The problem with these questions tends to be with the slope. So let's look over here again at our diagram. If you see this diagram, the slope is going to be, didn't we say it's perpendicular to this slope? It's at right angles to this slope. So I need to find the slope of this radius in order to find the perpendicular slope, which will be the slope of my tangent. Okay, so let's work on it over here. Okay, so the slope of the tangent is perpendicular to the slope of the radius. The slope of the tangent is perpendicular to, remember that means perpendicular. Okay, the slope of the tangent is perpendicular to the slope of the radius. So I need to find the slope of the radius. The slope of the radius is the slope of the line joining 0, 0 to minus 2, 2. Okay, the slope of the radius is the slope of the line that joins 0, 0 to minus 2, 2. So the slope of that is my y values subtracted over my x values subtracted. That's my slope formula. Or, as you remember, rise over run. So the slope of my radius is 2 minus 0 over minus 2 minus 0. y2 minus y1 over x2 minus x1. So 2 over minus 2, which is minus 1. The slope of my radius is minus 1. Now I've definitely got a high attempt mark. So let's say I've got 7 out of 10 for finding this and this. I might even have more, you never know. Now, my slope of my radius is perpendicular to my slope of my tangent, and I need the slope of the tangent. That's the key thing that I need, the slope of the tangent. If you remember, if you've got one slope, maybe I'll do it up here. If you've got one slope that's a over b, a perpendicular slope to that is minus b over a. We flip the slope. We flip the slope and change the sign. That's how we get a perpendicular slope. You flip the slope and you change the sign. Now this is a bit weird because this slope is minus 1. That's actually the same as minus 1 over 1. So to flip that slope is actually just plus 1 over 1. We flip the slope and change the sign. So a perpendicular slope to minus 1 is plus 1. Now when we come to do one later on where the slope isn't 1, where it's something like 3/4, the perpendicular slope would be minus 4 over 3. Or if the slope of the radius was 5 over 7, the perpendicular slope would be minus 7 over 5. The slope of the radius is minus 1. The perpendicular slope to that is plus 1. So I now have my slope. My slope of my tangent is plus 1. So I go back over here and I say my slope is y minus 2 is equal to 1 times x minus minus 2, remember, is x plus 2. So working through my equation, y minus 2 is equal to 1x plus 2. 1 by x is x, 1 by 2 is 2. And then if I want to, I can just rearrange it, because often using this equation, it's actually the easiest way to rearrange it is to make it into a y equals answer. So y is equal to x plus 4 is the equation of a tangent. The equation of a tangent to a circle at the point minus 2, 2. And that's my answer. So you can see why it's a I could know, because it's multi-step. Lots of steps there. And I'll write out those steps now in a minute over the page, but let's just highlight what they are. What are the steps? The steps are, we needed to check that we knew the point on the tangent, which we did. It was minus 2, 2. We called that x1, y1 because we knew the equation of the tangent is the equation of a line with this formula, y minus y1 is equal to m by x minus x1. Because we now knew the point that was on the tangent, we could sub in x1, y1 into our formula. We then needed to find the slope for our equation of our tangent. And we had to realize that the equation of our tangent was going to have a slope that was perpendicular to the slope of the radius. So we had to find next the slope of the radius. Having found the slope of the radius, we then had to flip it and change its sign to get the slope of the tangent. Having found the slope of the tangent, we had to sub that back in to find the final equation of our tangent. Multi-step problem. Okay. Let me write out the steps over here on the next page, and then you can ask me any questions. Okay. So, so steps to find the equation of a tangent to a circle. Okay, so these are the steps. Obviously, you know, this, you might do the steps slightly differently, but this is how I'm going to write them out for now. The first one is, you need to write down the formula for the equation of a line. The reason I start off with doing that is because that reminds us what we need to find. By writing down the formula for the equation of a line, I'm reminded straight away what I need. I need the point, x1, y1, and I need the slope, which is m. The second step is to find the point on the tangent, and that is given to you. So that's a nice step. That's given to you. So x1, y1. In the case we've just done, for example, in the last example we've just done, that was minus 2, 2. That was the point on the tangent. So it was the point of intersection of the line and the circle. Point of intersection of the tangent and the circle. Okay? So that point is always there. Okay? That's always our x1, y1. Now at that stage we may choose to sub x1, y1 into y minus y1 is equal to m by x minus x1. We might choose to do that at that point. Okay, just to get ourselves started. Now, because we've written down what we need to find the equation of a line, we now know that we need to find the slope of the tangent. And we know that that's perpendicular to the slope of the radius. So our next step is to find the slope of the radius using y2 minus y1 over x2 minus x1. Now, which points will we use for this? x1, y1 will be the point on the tangent, which was up here. Okay? And x2, y2 will be the center of the circle, which I'm just trying to think, I'd have to go back through all the papers, but usually that will be 0, 0, or often anyway, it will be 0, 0. So we're going to find the slope of the radius using the center of the circle and the point on the tangent. And then the fourth point is to find the slope of the tangent, the fourth step, which is perpendicular to the slope of the radius. And how we do that is we flip it upside down and change the sign. So if the slope of the radius was a over b, the slope of the tangent will be minus b over a. So for example, if the slope of the radius was 2/3, the slope of the tangent would be minus 3 over 2. If the slope of the radius was minus 2, the slope of the tangent would be 1/2. Okay, and then finally we sub the slope into the equation formula and work it through. Okay, so we've got our x1, y1 subbed in, we've got our slope subbed in, and we work that through. So there's my 5 steps. I can't quite fit them all on the screen at the one time. Let's move the book down a bit. Okay, still can't, but anyway, write down the formula for the equation of a line. That reminds us what we need. Find the point on the tangent that's given to you. Find the slope of the tangent by, first of all, this is really the step here, find the slope of the radius. Once you've found the slope of the radius, you can find the perpendicular slope to that, which will give you the slope of the tangent. Sub that into your equation and work it through. Okay. Just going to pause this and see if there's any questions. Okay, so I'm just finishing up this video by working through one more example. So in this next example, which is from the same book I took a photograph of earlier, we've got a circle x squared plus y squared equals 20, and it has a tangent at the point 2 minus 4, and here's what I'm being asked to do. I'm being asked to draw a sketch of the circle and the tangent. Draw a sketch of the circle and the tangent. And I'm being asked to find the equation of this tangent. Find the equation of the tangent. And then I'll do the last part just because it was in the book. Find the coordinates of the points where this tangent intersects the x-axis and the y-axis. So find the coordinates of the points where this tangent intersects the x-axis and the y-axis. Okay, so x squared plus y squared equals 20 has a tangent at point 2 minus 4. Draw a sketch of the circle and the tangent. So when it says a sketch, that's great because it doesn't have to be fancy schmancy. So here's my set of axes. Okay, and here's 0, 0. This circle is x squared plus y squared is equal to 20. So straight away I'm writing down the center of this circle is 0, 0, and the radius is the square root of 20. Now because I'm doing a sketch, I'm going to say that the radius of this circle is about 4.5. Okay, I'm only doing a sketch, so it doesn't matter, but just to have it. So 0, 0 is the center. Better use a pencil. A radius of about 4.5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. This is x, y, 5, 5, 5, and 5. So my sketch is going to be that it goes through here roughly. It goes through here. It goes through here, and it goes through here. Okay, not a great circle, but anyway. Okay, so it has a center 0, 0, 0, 0, and a radius of about 4.5. Draw a sketch of the circle and the tangent. Okay, the tangent is at the point 2 minus 4. 2 minus 4 is about here. Okay, so the tangent is there. Okay, at 2 minus 4. Find the equation of this tangent. So let's start this off. The equation of the tangent. So if you remember, I said the first thing to do is to remember that it's the equation of a line. So y minus y1 is equal to m by x minus x1. And what we've got here is we've got to remember that we need x1, y1, and we need our m, which is the slope, and this is the point. Now, the point on this tangent, they've told us, is 2 minus 4. So already I have my x1, y1. So y minus y1 is equal to m by x minus x1. Y minus 4 is equal to m by x minus 2. Y plus 4 is equal to m by x minus 2. Okay, so I've started off really well. I've subbed in my point x1, y1. Now, the next thing is I need the slope. So I need the slope of the tangent, but if you remember, it's perpendicular to the slope of the radius. So I have to find the slope of the radius. Now that's the slope of the line joining 0, 0 to 2 minus 4. Okay, it's this line here. Okay, that's at right angles there. Now, what's the slope of that? Well, if I call this x1, y1 and this x2, y2, the slope is going to be minus 4 minus 0. 0 minus minus 4, because it's y2 minus y1, over x2 minus x1, so 0 minus 2. So it's going to be plus 4 over minus 2, which is plus 4 over minus 2 is minus 2 over 1. So my perpendicular slope, okay, so the slope of the tangent is perpendicular to the radius slope. So the perpendicular slope to minus 2 over 1 is a slope of 1 over 2. So that's the slope of my tangent. So the slope of the radius is minus 2 over 1. The slope of the tangent is 1 over 2. So my equation of my tangent is y2 minus y1, is y minus y1 is equal to m by x minus x1. I've already done most of it. What I've got so far is it's y plus 4 is equal to m by x minus 2 from up here. So my slope is a half, so y plus 4 is equal to a half by x minus 2. So I can do this two different ways if you remember from your coordinate geometry. So let's go, one way is to say y plus 4 is equal to half x minus a half by minus 2 is minus 1. So subtracting 4 from both sides, you've got y is equal to a half x minus 5. That's one way. The other way is to multiply all across by 2. So 2 by y plus 4 is equal to 1 by x minus 2. So 2y plus 8 is equal to x minus 2. So let's bring it all to one side. And what we have is x minus 2y minus 10 is equal to 0. Now they're actually the same equation. They just look different, but they are the same equation. It's just in a different form. So that's the main part of the question, and find the equation of this tangent. The last part, if you remember, said find the coordinates of the points where this tangent intersects the x-axis and the y-axis. So find the coordinates of the points where this intersects the x-axis and the y-axis. I can see roughly here, I can see it looks like it's roughly at minus 5 and 6, 7, 8 and 8. So it looks like it's at 0, minus 5 and 8, 0. So that's a question mark, is it? We'll have to find out, of course, because that was just a sketch. So y is equal to a half x. So where it cuts the x-axis, y is equal to 0. Remember that? So y is equal to a half x minus 5. So if y is equal to 0, 0 is equal to a half x minus 5. So a half of x is equal to 5. So x is equal to 10. So it cuts the y-axis, sorry, the x-axis at 10, 0. And where it cuts the x-axis, the y-axis, x equals 0. So y is equal to a half x minus 5. If it cuts the y-axis, x is 0, so y is equal to a half of 0 minus 5. So y is equal to 0 minus 5, y is equal to minus 5. So it cuts the y-axis at 0 minus 5. So that was right. That one was right, but that one was off. Doesn't matter, that was just a sketch. Okay. Remember, where it cuts the x-axis, y equals 0. Where it cuts the y-axis, x equals 0. But the main part of this question was to look at that example to find the equation of the tangent is in the form either y is equal to half x minus 5, or the same equation but in a different form is x is equal to 2y minus 2, x, 0 is equal to x minus 2y minus 10. Okay, it's a tough one. Definitely a could know rather than a should know. Hopefully that helped.